Hello students, welcome. Let us discuss endothermic and exothermic reactions. So I will give you in detail explanation what is endothermic and what is an exothermic reaction. Let us begin with endothermic. So endothermic reactions are the reactions which involves absorption of heat. So in order to reaction to take place, let us say reactant A is converting to B. So in this reaction, in order to convert reactant into product, it needs some heat. That means energy is absorbed in the form of heat or light. Okay, so these are having gain of energy. So in these reactions, reactants gains energy to convert into product. Okay, so those kind of reactions are said to be endothermic reactions. If you see the energy change in this reaction, like enthalpy change, so enthalpy changes the overall thermal heat energy change in the reaction. You see this one for endothermic reactions, because already it has some energy, molecules have internally some energy, and additionally it is gaining some energy from the surroundings. So we say that delta H value is always a positive value. So delta H is positive. So gain of energy is indicated delta H positive. So coming to the examples of gain of heat. So let us see a few examples. First example, ammonium nitrate. Okay. Ammonium nitrate will gain heat, will take up the heat energy and converts into ammonium ion and nitrate ion. So it is a good example for absorption reaction, endothermic reaction. So in this case, in the normal examples of endothermic reactions, you can say all photochemical reactions which gains energy. Okay, they can be taken as an example. Similarly, conversion of so ice to water to ice. Okay, conversion of water to ice. Those can be taken as an example. So next one is sulfur trioxide conversion into sulfur dioxide and oxygen, which is said to be another one example for the endothermic reaction. It absorbs the heat in this reaction as well. Similarly, you can say ammonia, dissociation of ammonia into nitrogen and hydrogen gases. Nitrogen and hydrogen gases. So here also heat is absorbed, which is said to be an endothermic reaction. Similarly, calcium carbonate, dissociation into calcium oxide and carbon dioxide. So which involves absorption of heat. So these are all said to be examples of endothermic reactions. Okay, endothermic reactions. Now let us see what are exothermic reactions. So I just reverse to the endothermic reactions. Exothermic reactions involves release of heat. Okay, thermal energy will be released. So we can say in this case, the simple example of exothermic reactions are combustion reactions. You can say combustion reactions are examples for exothermic reactions. So here, let us say reactant A is converting to product B by releasing some energy in the form of heat. If you see the enthalpy change in this reaction, so here the reactant is losing energy while converting into a product. That means totally there will be loss of energy. So there will be a loss of energy. Always exothermic reactions involves loss of energy. So delta H value is said to be negative for exothermic reactions. Okay, enthalpy change, overall thermal energy change will be negative, means they are losing energy to the surroundings. How can we define exothermic reaction in simple words? Exothermic reactions are the chemical reactions which involves loss of heat into the surroundings. Okay, coming to the examples of exothermic reactions, you can say formation of ammonia from nitrogen and hydrogen. Okay, so it gives us ammonia. So generally it is a reversible reaction. You can say this forward reaction is a exothermic reaction and the backward reaction is an endothermic reaction. Okay, 2 moles of ammonia. And you can say conversion of sulfur dioxide with by reacting with oxygen, it converts to sulfur trioxide. Again, it is a reversible reaction. So where the forward reaction is said to be exothermic and the backward reaction, the dissociation of sulfur trioxide to sulfur dioxide is said to be endothermic. Already I gave that example in that case. Similarly, calcium hydroxide, calcium chloride. You take calcium chloride reaction. CaCl2, calcium chloride, okay, undergoes reaction with water and converts to calcium hydroxide plus 2HCl. In this reaction, heat will be liberated. Okay, so this is also one of the example for exothermic reaction. Reaction of calcium oxide with carbon dioxide gives us calcium carbonate, and heat is liberated in this case as well. So if you see all these exothermic reactions, they are releasing energy to the surroundings. That means you feel hotness when you touch the reaction vessel. Whereas in endothermic case, in exothermic phase, in endothermic, you feel the coldness because they are gaining energy from the surroundings, so that the energy of the surrounding heat energy will be decreased. That's why you feel the coldness. Okay. So let us see graphically how can we show exothermic and endothermic reactions. Okay. So I'm explaining comparatively. So this is energy axis and this is a reaction coordinate. Okay, I took energy y-axis as energy axis and x-axis as reaction coordinate. Similarly here also energy axis and this is a reaction coordinate. Okay, reaction coordinate. So here in this graph, let us say the reactants have this much of energy and the products have this much of energy. And they are converting into products, right? Reactants are converting to products. So if you see here, there is energy difference between the reactants and products. And reactants are having low energy, the products are having high energy. Means this is said to be the energy difference between the reactants products, which is having high energy, is said to be the gain of energy. Gain of energy or heat. Okay, so this reaction is involving the form endothermic case. So endothermic reactions involves a gain of heat, where you can see that graphically here the reactants have lower energy on the energy axis, whereas the products have this much of energy. From where they got this high energy, they are absorbing from the surroundings. That's why we said it is a gain of heat. Similarly, in this case, the reactants have this much of energy and products are having this much of energy and they are converting to products. And this is said to be transition state. Transition state. Okay. So the energy difference between the reactant and the product, if you see on the energy axis, reactants are having high energy, the products are having low energy. So that means this and much of energy should be lost to the surroundings. So energy lost to the surroundings. Okay. So in this way, you can simply understand how the reactants are converting into products in endothermic, and this is an exothermic case where the energy will be lost in the form of heat to the surroundings. So that's all regarding endothermic and exothermic reactions. Hope you understood this topic clearly. Thank you for watching.